Hello friends, welcome to IIT Masterclass. So today, let's start a theoretical discussion on the third chapter of this book, Concepts of Physics by HC Verma. So in the third chapter, the book talks about rest and motion kinematics, which is actually the first physics chapter of this book. And here, what are we going to discuss? So I have outlined few of the topics that we will discuss in this video, and the rest in the later videos. So first we will be talking about rest of motion, second distance and displacement, average speed, instantaneous speed, average velocity, instantaneous velocity, average acceleration, instantaneous acceleration. So let's go ahead. So first of all, rest and motion. How do you define that a body is in motion or is it in rest? So you might say it's a simple question. If a body does not change its position with respect to time, it is said to be stationary. And if it does change its position with respect to time, it is moving. But how do you know whether the position is being changed or not? To give you an example, let's say you are traveling in a train, okay, and the train is right now stationary on a platform. So while you are inside the train, a person on the platform, he will see you as stationary, right? But let's say this train, gave a big whistle and it slowly started moving on the tracks. Now, the person seen from the platform will see you moving along with the train. So now, from the perspective of this person standing on the platform, you start moving with the train. But what happens from the frame of reference of a person who is standing next to you inside the train? So there, from that person's point of view, you are still stationary. So that means you are moving with respect to one frame, that is the frame of reference attached to the platform, but you are stationary from another frame of reference that is attached to the train. So actually, when we speak about motion, it actually depends on which frame of reference we are making the observation from. So frame of reference or the viewer is equally important as the object that is undergoing motion. Okay, but to analyze and to understand and to describe motion, we need to first fix our frame of reference. Okay, so in our discussions here, and generally we consider the frame of reference as the ground. So let's say when I say speed of the car is 50 kilometers per hour. So this means 50 kilometers per hour from a frame of reference attached to the ground or attached to the earth. Okay, so first thing is we need to fix our frame of reference. Okay, so now we have understood the importance of frame of reference. We will come back to that later. Now let us define these very important basic terms that we are going to use while we study kinematics or study of motion. Okay, so first is distance and displacement. Okay, so till now we might have used them interchangeably, but there is big difference between distance and displacement. What is the difference? So I'll give you an example. Let's say I was standing at point A, okay, and then I moved straight, let's say by 5 meters. So then I reached point B. Then again I moved by 5 meters. I reached point C. Okay. Then again I moved by 5 meters. So I reached point D. Now I decide to turn back towards DA. So from here, I travel in this direction and reach again at point C. So can you tell me what is the distance that I travel? Yes, the distance is AD plus DC. So this is the distance that I travel. Okay, which is equal to 20 meters. But what is the displacement that I have at the end of my full journey? The displacement is just the difference between the initial position and the final position. Okay, so my displacement from A is AC, and that is 10 meters. So although my distance is full 20 meters, whatever distance I traveled, but my displacement from point A is only AC or 10 meters. So this distance is the total distance covered, while displacement is the change in the position of a person or a body or a particle. Okay. Now let us come to the next topic, that is average speed and instantaneous speed. Okay. So let us try to understand this by way of a simple graph. So we have y-axis here, we have x-axis here. Let's say I denote distance covered by a body in my y-axis, and x-axis is the time it takes to cover that distance. Okay, and I say that let's say it is a curve like this. Okay. So now let's say the body was at time t1 at a distance s1 from origin. So this is my frame of reference. Okay, my frame of reference is this axis. So now let's say the body reached in time t2 a distance s2. Okay, let's say this point is A, this point is B. So now what is the average speed? So average speed, or V average, is given by total distance covered by the body in a particular time. Okay, so what will be the total distance covered by the body from A to B? It is S2 minus S1 upon T2 minus T1. So this is pretty simple. So this is the average speed of the particle or the body between A and B. Okay, so now let us talk about instantaneous speed. Okay, so like the name suggests, it tells us what is the instantaneous speed of the particle at any point. Okay, so like it spoke about average speed. Average speed means, you know, this body might have higher speed at these points and lower speeds at this point. But what we are interested in average calculation is what is the average speed in the time window. Okay, but instantaneous speed means I need to find out what is the instantaneous speed at any particular instant of time. Okay, and as you see, the slope of this curve changes at every point. So what is speed? Speed is actually the slope of S and T curve. Okay, so the speed, let's say at an intermediate point x, is equal to the slope of the tangent there. So if this is the tangent, this line, so this gives me the instantaneous velocity at point x. Now how to calculate it? Okay, so let's say I connect points A and B. Okay, and I say that this is, let's say, dt, and let's say this is del s. So I say del s by del t is also V average, right, in this particular time window dt. Now I need to find the tangent on this graph at this point, right, like this. So I need to find the tangent on this graph at point A. This will give me the instantaneous velocity at point A. Okay, so now if I use the technique of differential calculus and I make this dt very, very small, so what will happen? This AB will slowly, you will see that B will try to converge towards point A, and this chord AB will become the tangent to the graph at point A. So when I say limit dt tends to 0, so ds by dt, this becomes ds by dt. Okay, so this is called instantaneous velocity or instantaneous speed. Also, we need to understand that when we have a vt curve, let's say we have a velocity time curve, something like this. Okay, so we know that v dot dt gives me ds. So any small time dt, so the area of this gives me the distance that the body travels in this dt time. Okay, so if I have to find the distance it travels from point t1 to t2, what do I need to do? So that means I need to integrate this v dot dt. So that means area of the vt curve gives me the distance traveled. Okay. So now let us try to understand so this we are done, average velocity and instantaneous velocity. Okay. So for this we will have to understand the position vector. Okay. So let's say this is my origin O. Okay, and this is my x-axis, this is my y-axis. So let's say there is a particle here. Okay, so it is at point A, and its position vector is r1. So what does this position vector means? This means the position of A with respect to this coordinate system. Okay, so what is the position of A? r1. So r1 means this OA mod of A and the direction as well. Okay, so now this particle does some movement and it reaches point B. So what is the position vector? r2. So what is the displacement of the particle? In this direction. Okay, so as you know, displacement is a vector. Okay, distance is a scalar, displacement is a vector. So we can see from triangle rule of addition of vectors that AB is given by R2 minus R1. So the displacement in the frame of reference O is given by the difference of the position vectors of A and B. Okay. Now let's say this displacement is done in from t1 to t2 time. Okay. So then V average, that is average velocity, is r2 minus r1 upon t2 minus t1. Okay. So velocity, as you see, is a vector quantity because displacement is a vector quantity. Okay. And now instantaneous velocity. So what is this actually? I can say this to be del r by del t. Okay, change in the position vector in time. Now if I have to find the instantaneous velocity, so then I do the same thing that I did with speed. So I make this del t very zero. So as the del t goes to 0, then the chord actually becomes the tangent to the curve, and the tangent to the curve is the velocity. So instantaneous velocity can also be called just velocity. Okay, so this is the velocity. Okay, so now let us learn about average acceleration and instantaneous acceleration. Okay, so A average is equal to, so what is acceleration? Acceleration is rate of change of velocity. Okay, so let's say if the initial velocity was v1 and after a time period it becomes v2, so the average acceleration is change in velocity upon the time that it took for the change. Okay, and what is instantaneous acceleration? So we denoted by A is also a vector quantity. So instantaneous acceleration will be del V by del T and lim del T going towards 0. This becomes dV by dt. Okay, so this is average acceleration and instantaneous acceleration.